Hey everyone, today I'm back with another handheld cordless drill repair. I've been meaning to spend more time on this topic because it's something many people run into, and I'd like to share what I've learned along the way. So let's take a look at this old, broken drill I've got here and figure out what's going on. If you got a worn-out cordless drill sitting somewhere in your workspace, go ahead and bring it out and we'll work through it together step by step. To get to the root of the problem, I'll start by checking the standard battery pack on this cordless drill first. The simplest way to do that is to place it on a dedicated charger and see whether it's actually taking a charge or not. It looks like this battery isn't taking a charge. Normally, if it were, the charger's indicator light would switch from green to red right away. And that's not all. I'll go a step further by checking the positive and negative terminals of the battery using a simple test tool. If the tool responds, it means taking the battery apart and repairing it will be much safer. Luckily, the tool shows no response at all, which means it's safe to proceed. There's no need to worry about any leftover charge inside the battery. Just to avoid any doubts about the results being staged, I'll mark it so everything stays clear and transparent. Once I'm sure there's no stored energy left inside the battery, I'll open up the outer casing to see what's going on inside. There's a small detail that often gets overlooked. It doesn't cause immediate problems, but over time it can shorten the tool's lifespan. Fine layers of dust and tiny traces of rust, they're hard to spot with the naked eye. That's exactly why proper cleaning and maintenance matter so much. After brushing off the first layer of fine dust with a paintbrush, I'll clean it further using WD-40 multi-purpose oil. The reason I use this is because it helps loosen stubborn dirt, removes light rust, and leaves a thin protective layer that helps prevent moisture from building up again. To get a better cleaning result, go ahead and prepare a small piece of sandpaper like this. It helps deal with stubborn spots that a brush or oil alone can't fully remove. Next, I'll use a screwdriver to gently loosen the circuit board. The goal here is to check if any wires are pinched or trapped inside, which could be blocking the flow of power. If I find anything like that, I'll carefully free it. And you might think that's the end of it, but not just yet. There's still one final step. We're going to make a simple tool to help restore a battery that won't take a charge, using basic materials that are easy to find in most hardware stores. Here I've got a 2x8 terminal block, a type of connector that's commonly used to join and secure electrical wires while keeping the contact stable and safe. I'll be reusing 2 of the metal connectors inside it, since they provide a firm grip and good conductivity. These will become part of a simple homemade tool to help restore a battery that won't take a charge. The 2 short wires I'm using are the kind with an outer insulating layer and a core made up of multiple tightly braided copper strands. This design helps them stay flexible while still conducting electricity reliably. On one end of each short wire, I'll attach a metal connector from the terminal block. As for the other ends, I'll leave them for now and handle them in the next step. As for the remaining ends of the 2 short wires, I'll attach an alligator clip to each one. These clips make it much easier to connect securely to a power source when needed. It makes a lot of sense to use a small battery as a supporting power source of this tool, helping to wake up a battery that's in a dormant state. The reason is simple. It can provide a steady and moderate level of power, just enough for the battery to handle without putting it under too much stress. And there's one important thing to keep in mind. Always match the correct polarity when making the connection to avoid a short circuit. Even when done properly, this is still a workaround, so it can reduce the lifespan of the battery cells. It's best to check every 15 seconds and keep monitoring until the battery starts working again. Looks like it worked. Now I'll leave it on the charger and let it charge all the way up to full. even though it's working now. To make sure it's stable, I'll test it in real conditions by putting the battery back in the drill and trying it out. And there you have it, folks. Our old, sleeping cordless drill battery is fully awake and ready to go. What started as a simple check turned into a complete restoration project. Along the way, we went through safety checks, careful cleaning, minor repairs, and even a homemade tool to revive a dead battery. The key is patience and attention to detail. Rushing any step could damage the battery or shorten its lifespan. By taking your time, you not only get your drill working again, but also learn how these batteries function and how to extend their life. So next time you see an old cordless drill gathering dust, don't throw it away. Grab it, follow these steps, and bring it back to life. With just a little care and know-how, even the oldest tools can perform like new. That's it for today. Thanks for watching, everyone. I hope you enjoyed it and picked up some tips for reviving your old tools. Stay curious. Keep tinkering, and I'll see you next time. Take care and goodbye.